Well, greetings out there in YouTube land, and welcome to today's big video, which will not be repairing an amplifier. There's no boxes out in the workshop to be opened. In this case, I anticipate probably a 2 or 3 part video series featuring a amplifier circuit that caught my eye years ago, and I always swore that someday I would make or build one from scratch to see how it worked. And it's it's a Gibson, a GA1-RVT. Now, why, you say, did that catch my eye? Well, here's the deal about this circuit. Talk about economical. It uses 3 tubes to produce not only a single-ended output, but also to provide both reverb with a spring reverb tank and tremolo. And I just couldn't get over that, how you could use just 3 tubes to accomplish the triple threat in amplifierdom. Now granted, there is a 4th tube, a 5Y3 rectifier, and I considered going to diode rectification so that there would only be 3 tubes visible. But then I thought, no, you know, the 5Y3 tube rectification is really the way the circuit was originally designed, and far be it from me to change things. Also, I tend to reserve diode rectification for higher output amps, like 50 watts to 100 watts. And on a little rascal like this, with very low output, as we will see, it's just not necessary. So we're going to stick with the 5Y3, and I might try to hide it or kind of put it in a separate place from the 3 main and featured tubes. Now you may be asking yourselves, as I did when I first saw this circuit, is how with just 3 miniature tubes can we achieve the trifecta of amplification with both a spring reverb and a bias modulating tremolo. We see that the output from the oscillator is going to go up here, and just as it is done in the much larger amplifiers for bias modulation, we're going to feed that into the grid of our output tube and modulate it. So this little rascal with minimal components is going to offer some really stellar features. Now to do this, it's going to use some very unusual tubes. We see here 7199, which has become extremely rare and is prohibitively expensive now. So I've decided to use a valid alternative for it, which will give us the same performance, but with a tube that's very affordable and easy to get. I don't want to build something here that you all can't build on your own. So we're going to change this. If we look in here, we use a 6EU7, and it's a duo triode. Now, some of you, if you decide not to hunt down a 6EU7 or you don't have one on hand, you can use a 12AX7. And all you'll have to do is just change the terminals on the tube socket to which you will attach each of the wires in the circuit. I'll talk about that later. And then for output and tremolo oscillation, we're going to use a 6BM8 tube. Now, all 3 of these tubes are complex in that within one glass envelope, here we have a pentode and triode of the 7199. Here we have 2 triodes in the 6EU7, and on the 6BM8, once again, we have a pentode for output and a triode for our tremolo oscillator. Let's start out with V1 and discuss the nature of the tube, and in this case the substitution of an easily obtained 6AN8 tube for the very elusive and expensive 7199. We use the same tube socket, and all we do is change the terminals to which we attach the the wires of the circuit. So I've left the schematic as is and merely numbered the terminals of the socket differently to match the 6A and 8 rather than the 7199. Now it's rather ironic that although I have several 7199s in my tube stash, I did not have a 6A and 8. So in order to get the elusive 7199 replacement, I actually had to order this tube. I haven't gotten it yet. All our parts are going to arrive maybe today or tomorrow. Okay, and we'll open them up and discuss them when that happens. But meanwhile then, we're changing that to a 6A and 8. And it will be utilized with the pentode in the preamp position and the triode in the reverb driver position. Okay, so pentode, triode, first stage of amplification, and driver for the spring reverb tank. Next we look in here at the second tube in the amplification chain, and that's going to be a 6EU7. As I said, you can use a 12AX7 if you wish. Just pay attention to how you number the terminals of the socket and attach the wires, and the substitution's easy. 6EU7s are far less common. I happen to have, like I said, I have several of these on hand, so I'm going to go ahead and use it to try to preserve as much as possible of the original circuit design. But you won't gain anything with a 12AX7 because the amplification factor for both the 6EU7 and the 12AX7 is 100. Also, you notice in this case we have a 6-volt filament for the tube, whereas in the 12AX7 you'll have to wire it in parallel, the heater, so that you can get the 12 volts heater voltage with the 6-volt output from your power transformer. We see that the 6EU7 here is going to be the second stage of amplification and the preamp chain, and that's one triode, and the other triode is going to be the tube that receives the signal from the spring reverb tank and injects it into the circuit. And the final tube, the V3 in our circuit, will be the 6BM8, which has a pentode and a triode that are enclosed within the glass envelope of a single miniature tube. And we see that the pentode is going to be used for single-ended output to our output transformer and ultimately to our speaker, whereas the triode portion of the 6BM8 is going to be used as a rather traditional oscillator tube for our bias modulating tremolo. Now, something that has to be discussed is the choice of transformers. We'll have to buy 3 transformers for this build. And of course, typical of Gibson, they've given us absolutely no information to guide our choice. So I have gone through what's available at economical prices, and I've come up with a very affordable and appropriate output transformer, power transformer, and reverb driving transformer. And all 3 came from Antique Electronics Supply, and I will provide in the description for this video a link to the parts list. I know I said I wouldn't be giving you parts lists anymore, and tough love and all that, but on this particular one I'm going to, and like I said, I'll give you a link to it, but I will give you the information on the 3 transformers that you need so that you can order them. And they're very inexpensive. The output transformer up here is only $16. The reverb driver is $11. and the power transformer is $48. Okay, so that's not going to break the bank, I don't think. And in each case, they provide every bit of the performance and specification that we need, and perhaps a little more. So as you can see, this will be a fairly economical build. Also, on this one, I'm going to hand build the chassis for this. I'm going to use a 16 gauge steel. I know that viewers of some of my previous videos on scratch builds will remember fondly the horrible experiences I had using 16 gauge steel in a previous video. I think that was for the Reverb, which involves sledgehammers, restraining orders from the neighbors, and lots of cussing and injury and everything else. Well, remember I built a sheet metal brake in the last video series I had for a amp build. I'm going to use it. And I've got a couple tricks up my sleeve, but I can tell you that I'm very optimistic that our 16 gauge steel is going to turn out to make a really stout and very attractive chassis. On the cabinet, I've decided to try something a little different. Now, in the past, I've gone into the workshop and got out my table saw, created a finger jointed cabinet, did all the routering and everything else on it, and then upholstered it. And some of you don't have access to woodworking tools, and I thought I'm going to try something different. Since I started doing that, a couple companies have come up with some beautiful replica cabinets that are made exactly as the originals, the same dimensions, everything, and they're completely covered with tweed. They're essentially perfect, and they're very affordable. To be honest with you, if you offered me $1,000 to hand build a tweed cabinet for this particular amp, I would probably want $1,000 just for the misery and the time and effort and frustration it takes, especially if you're going to cover it with tweed. But I found that Mojo Tone offers, they don't offer a GA1-RVT cabinet, but they have a 5E3 Deluxe cabinet that I think will suit our needs perfectly. It's absolutely perfect looking, at least in the pictures. The dimensions are exact, and it's $350. And I'm telling you, if you haven't built your own cabinet yet, that's cheap. Okay, not only the wood, the material, the supplies, you're going to have to lacquer coat it. It's a nightmare. Okay, so I'm going to try to avoid that and come up with what I think is a very valid suggestion to sort of facilitate the process of scratch building nice looking amplifiers. I've also arranged with Mojo Tone and I've gotten a code that viewers can enter if they want to order the same cabinet, a 5E3 Deluxe cabinet, and you'll get a 10% discount, and I believe they offer free shipping. So you'd be looking then at what, about $315 for the most beautiful, perfect 5E3 cabinet you could imagine. Now, I don't have it yet. It probably will arrive today, and we're going to go over it, every square inch of it, and see if it really is of the quality and appearance and all that we really want and need. And if it is, I'm telling you, at $315, it's the biggest bargain you've ever seen. So that remains, however, to be seen, and we will check it out very soon. The code will be provided in the video description, so that if you want to order a 5E3 cabinet from Mojo Tone, for like the next 3 months or so, they will give you the 10% discount. One more component that needs to be discussed is the choice of spring reverb tank, which of course is not provided to us any information to help us from Gibson, but I thought about using little short ones and kind of lower performance tanks, and I thought, heck no. Let's go with the standard Fender dual spring long reverb tank, the 4AB3 C1B. And I'm going to use a reverb driver that is appropriate for that tank, a Fender style reverb driver. Now granted, we'll be driving the tank with a single triode here instead of the normal way of driving reverb tanks that we have seen in Fender circuits, which might be a 12 AT7. If you recall, they normally use both triodes of a 12 AT7 to drive the Fender reverb tank, and we're going to be driving it with a single triode. So if there is a shortcoming in the circuit, it may be that the reverb will not be particularly strong. We'll see, and we're also going to see on any of the shortcomings that might happen here. I'm going to try to fine-tune the circuit to make it work really great, and in so doing I will modify the schematic and then come up with a final schematic to which I will give you a link in probably the second or third video so that you can go and download that schematic and incorporate these changes and improvements that were sort of discovered by trial and error as we build this circuit. Also, I'm going to go with a 12-inch speaker. I happen to have some vintage Jensen speakers from the 60s, 12-inchers, that I think are going to be ideal for this and should give us some really fabulous tone, I'm hoping. And that's going to fit in with our 5E3 Deluxe cabinet. The baffle will come prepared for the 12-inch speaker. Let's finish up here with a brief review of how this circuit works, and then we will proceed to receive our parts and discuss them, build our chassis, and hopefully complete our project with great success. Okay, let's start off here. We see that, as I've already said some of this previously, but let's put it all together in some hopefully coherent presentation. You see the pentode of the 6A and 8 is going to be the first preamp tube. It's going to receive the signal from the two input jacks. Those of you who love preamp pentode tubes are going to be very thrilled with this, I'm sure. Now we're going to come over here, and this starts to look fairly complex, but here's what's going to happen. We're going to take some of that amplified signal and send it through a 2 meg pot, which is going to be able to adjust the amount or intensity of reverb, and we're going to send it down here to the grid of the reverb driver triode, the triode part of the 6A and 8. The output from the plate is going to go to our reverb driver transformer, be fed into our I'm going to order a mod tank. I like the sound better about our mod full-size 17-inch reverb tank, and then it will be then sent, our wet signal will be sent to the grid from the triode of the 6EU7, and we see that the plate then will feed out and be injected into the regular music signal from the second stage of preamplification, which is the first triode of the 6EU7. That signal, wet and dry, will then come over here and be fed into the grid of our output pentode, the pentode portion of the 6BM8 tube, through our output transformer and sent to our 12-inch. Pause this video for an emergency announcement. You know, I get to thinking about that 60-plus-year-old vintage speaker. And I got to thinking, you know, it's going to sound great, but for how long? You know, this is a fresh build with all new components, and I just thought it might be better to use what is essentially a brand new Weber 12A 125 S 4 ohm 30 watt speaker, and that's the part number. Now this jewel is the same color and looks virtually identical to the vintage Jensen that I was going to use. However, like I said, it's essentially a brand new speaker. It kind of will fit in with all the new components and give us what I think will be great tone, and probably for a lot longer than I'm going to be around to hear it. Okay, so this is the new choice. I hope you approve. As I said earlier, the one of the triads here of the 6EU7 will be this is a very traditional looking tremolo oscillator. You're familiar with, in most cases it's 0.01, then 0.02, 0.02. In this case it's 0.03. This might be a slow tremolo. We'll see. We'll be able to turn the tremolo on and off with a foot switch or maybe a toggle switch on the chassis, and we have here a tremolo adjustment which will be for our speed. Okay, that's about it, I guess. So this will be our reverb intensity, this will be our tremolo speed. Up here is our volume control. Maybe there's a tone control here, let's see. You know, if there is no tone control, and there may be, I'll look closer at this, we'll put one in. Okay, I really think we need a tone control. So, that's it. I think it's time then to get started. Our next few steps then will be chassis creation, which should have a lot of suspense and drama. Hopefully not as much as the Tremolo video. And we'll move on. Okay, so let's get started. Well, it's time to begin the fabrication of the chassis for our GA1-RVT clone. And I happen to have on hand a good sized sheet of 16 gauge, that's 60 thousandths thick, hot rolled sheet metal steel. Okay, and that's what I'm going to use. Now, in a previous amp building video series several years ago, I tried to use 16 gauge and almost ended up in the hospital. But with the trusty brake that I've constructed for sheet metal, I'm confident that we'll have a lot better luck this time. Now, cold roll steel is shinier silver. The hot rolled, it tends to be kind of a blued appearance. And since I'm going to paint the chassis, I thought this stuff would work just fine. Okay, the hot rolling, they quench it afterwards, it's my understanding, which gives it sort of a temper, and it's a little more resistant to bending. It's a little tougher than the cold rolled steel. So it'll make a better chassis, but on the other hand, it's probably going to be a little harder to machine. Well, enough whining about that. I think it's time to get started. Now, from my research on the internet, I found that the 5E3 Deluxe chassis, which will fit the cabinet that we'll be using, is 60 thousandths of an inch thick, which is 16 gauge steel, which is actually rather thick. Okay, it's 14.5 inches long, and these are the dimensions. There's a 3/8 inch lip, 2 5/8, 4 1/8, 2 5/8, and 3/8, which adds up to 10 1/8. So I've marked off here on my sheet 14.5, and I'm going to come across over here to 10 1/8 and draw the perpendicular edge, and then I'm going to use my cutoff saw to go ahead and cut out this rectangle of 16 gauge steel. Now, just to be sure that my homemade sheet metal brake could actually bend 16 gauge cold roll steel, I ran an experiment with a piece of the material and about the same width, the 14.5 inches, and as you can see, it made a really nice 90-degree bend. So I feel confident that my homemade brake here is up to the challenge. And there you see a nice smooth 90-degree bend made in 16 gauge steel. Okay, so now let's continue cutting out the rectangle of material we'll be using, and then we'll start bending this into the shape of the chassis. And there, with the help of an angle grinder and a brand new 4.5 inch disc, we have our rectangle of steel that will form our chassis. We see that it is 14.5 by 10 1/8. Okay, so now it's time to proceed with the bending and forming of the chassis. Now, starting with a center line on our metal rectangle, I've measured for the back wall of the chassis, which is 4 1/8, and then a 2 5/8 inch top and a 2 5/8 inch floor, with this material left over to be the little lip that curves up at the bottom. Now, to facilitate the bending process and to make the bends sharper and closer to a 90-degree bend than just a sweeping curve, I'm going to groove the inside of the steel with my cutoff blade. I'm using a piece of angle iron here as a straight edge, and I'm going to cut down maybe a third or quarter of the way through the metal along this straight line at each of those bending marks. Here you see the grooves that I've cut into the bend marks on the back of the 60 thousandths thick piece of sheet metal. These are going to facilitate the bending process, as I said, both as far as reduce the exertion required to make the bend and also reduce the radius of the bend and just make the line straighter and the whole job easier and better. Okay, keep your fingers crossed. I know I am. I try to make the grooves about, I'll say 20 thousandths deep. As you can see here toward the edge, it got a little deeper than that. But the idea is, of course, not cut through, but just to weaken the metal in the line here that I'm going to bend along. The metal is now secured in our sheet metal brake with the groove right along the leading edge of the radius tool, and now we're going to lift out here on the drawbridge and bend hopefully a beautiful 90-degree angle in this lip. Now, small pieces like this are much more difficult to bend than large pieces. So let's see, this will really tell us how this is going to work out. Well, we're halfway finished. The little lip here was, as was predicted, really tough. I had to end up putting it over this edge right here and tapping with a hammer to kind of smooth out the little undulations in it, but it turned out fine, and this big bend here worked out just perfectly. It was quite simple. I think the groove really helped. Now let's do the other half and our chassis will be shaped. Then we have to worry about making, fitting and welding the end pieces. Well, there's the final bend, and you can see the side view of the chassis. I've got to make sure that now I'll go back and double check that I have exactly 90-degree bends at all four positions, and then we're ready to start work on the side pieces. I think it's worth noting just how sharp and uniform the bends are on this 16 gauge steel. I really think that grooving down to like 1/3 of the thickness of the metal really made a difference and facilitated these almost perfect 90-degree bends. Okay, we're all squared up, and as you can see, looking pretty good. So now, like I said, time to start cutting out those rectangular end pieces. Well, I finished one of the two end pieces. I cut it so that it had an interference fit into the end of the chassis. Then I tack welded the four corners to hold it in place. Now I'm going to start welding along the edges, and then I'll grind them down, and hopefully it'll look like it's all one piece when I get through. There's the end piece welded in place all the way around, ground down flush, and now it's time for a little glazing putty, and then we'll move on to the other end piece. The advantage of welding externally is that the interior corners are perfect, no sign of welding or anything else, and this is the part of the chassis that will be visible when the back door is removed from the end. Then a little primer to prevent rust, and it almost looks like it is one piece, doesn't it? Now it's time to do the other end of the chassis. Well, the other end has been cut to an interference fit. It is tack welded in all four corners, and now it's time to do the finish welding along the seams. There, the welds have been completed and are ground down to nice straight square corners. Now it's time to do a little finish sanding here on the scratches, and we'll do some glazing compound and then a little bit of primer. We'll see how it looks. Here's the chassis. The fabrication is now completed. As you can see, the corners are nice and sharp and clean, and now it's time to start drilling the holes for the tube sockets, transformers, switches, controls, pots, and all of that. Earlier in the video I mentioned using a glazing material. Well, it's a putty that comes in a tube, and you rub it on over like welding and grinding and things like that in little pinholes, and it fills in all the imperfections so that when you sand it will look like the surface is just flawless. It air dries in a matter of 15 or 20 minutes. Now, it's not for filling any kind of deep flaws or anything like that. It's strictly for little, almost microscopic little hairline scratches and pinholes and things of that sort. But as you can see, it did a pretty good job. And I should add that this glazing putty is available at any car parts store, like O'Reilly's, Advance Auto, any place like that. So if you want to give it a try. While ordering components for our GA1-RVT circuit, I was stumped in that I could not find a 2 meg pot with an audio taper. Now, granted, some of you may know where to find them, but I didn't. So I did the next best thing. I figured out a way to make one. So step one was to hunt down a ganged double 1 meg audio taper pot. This is two 1 meg pots, and when you turn the knob, you're sweeping the upper one and you're also sweeping the lower one. Okay, so that was step one, and it was strange that I could find this, but I could not find a 2 meg pot. But that aside, and let me show you how you wire this so that it magically becomes a 2 meg audio taper pot. Now, for clarity's sake, I separated the two potentiometers, so this could be the upper one and that's the lower one. All you do is jumper from the left terminal of the upper one to the left terminal of the bottom one, and then connect your wipers to the circuit. Now, when you sweep the double or ganged pot, you will have a 0 to 2 meg audio taper sweep. And to prove that, let me demonstrate. Step one, I connect the two probes of my ohm meter to the central terminal, which is the wiper. Next step is to jumper from the left terminal of the upper pot to the left terminal of the lower pot, as was shown in the diagram. Now, to see if it works, let me demonstrate. The wiper shaft is now in its extreme counterclockwise position, and we have essentially a zero resistance. Now watch as I sweep from left to right. I have to slow down so the meter can catch up. And there we have around 1.9 million ohms. Okay, the lower pot isn't exactly a 1 meg. There is some, imperfection in these rather inexpensive potentiometers, but I think that's close enough to 2 to work for us. Let's crank it back down, and we see that we can get down to 0. So this type of wiring works perfectly, and we've converted a dual ganged 1 meg pot into a single 2 meg. Well, I'm getting the pilot light sorted out for our chassis, and a viewer sent me a device that he either found or had made, but it's an LED bulb and it also changes color. Let me use the Variac to give us 6.3 volts or thereabouts, and let's watch it in action. Let's watch it go through all its color changes. It's blue. I'm not sure, I guess that's kind of a whitish. Oh, that's pretty. Vivid red. Green, and back to blue. Pretty snazzy. And with several of the bulbs, he sent me this white jewel that will diffuse the colors. And I don't know if he's going to sell these or make them available. I'll find out, and if so, I'll put a link in the video description in case you'd like to get some of these real fancy color changing LED bulbs. I think that'd be a neat touch. I'm going to include this then on our chassis. Well, a full week has passed since I ordered parts, and I'm getting a little frustrated. These are the ones that I had on hand, and I'm going ahead now and trying to lay out the chassis without the cabinet and without the new parts. First off, my order from Antique Electronics Supply, which is in Phoenix, about 450 miles away on Interstate 10, went to Salt Lake City, and then to Albuquerque. So hopefully we'll get them today. And then through a miscue at Mojotone, the shipping of the cabinet was delayed by about a week. So I won't be receiving it during the production of this part 1 video. It should be here in several days, and so we'll have to wait to part 2 to see and evaluate the cabinet. Meanwhile, we might as well get started on the machining of the chassis in preparation for the arrival of that cabinet. Well, I'm doing my preliminary layout of the components on the bottom of the chassis. They will be facing the cabinet floor. You see the 3 mini tubes involved in amplification, the 4, 8, and 16 ohm speaker outputs. This will be for the reverb tank in and out shielded cables. The fuse is going to have to be on the bottom because there's no room for it on top. And here is our 5Y3 rectifier socket. Last but not least is a part I forgot on my last bill, which is a hole for the AC cord to enter the chassis. Okay, so once I get this sort of balanced where it looks good, I'm going to make detailed measurements and marks on the tape-covered chassis surface and begin machining the holes for these components. Well, this is what I came up with for the bottom of the chassis. The 3 amplification tubes are nicely spaced to facilitate cooling. I moved the reverb cable jacks, the RCA jacks, behind the speaker output jacks to get them up toward the front of the chassis to make them easily accessible, and I'll probably label along this edge here for 8 and 16 ohms to enable you to know exactly what you're plugging into. Then the fuse will be evenly spaced between the rectifier tube socket and the in-output jacks. Okay, now I'm going to mark this and make sure that all the distances are exact, and then we can start drilling. As you can see, the dimensions are all finalized and measured for perfect spacing. At the intersection of each of these lines where the hole will be drilled, I've put the diameter of the bit that should be used to drill the hole. Down here I need to get out my cord and grommet, and I will measure it and determine that hole diameter. So with everything then clearly marked, I think we're ready to get out our punch, dimple each of these spots, and then begin drilling the floor of the chassis. Step 1 of the machining process, I drilled 1/8 inch pilot holes at the centers where each of the holes for components will be drilled. For these two, 1/8 is all it takes, so I'll probably cover them so that there's no confusion. Okay, I still have to drill this one, and then I'm going to start probably with a step bit and start working up these larger diameters. All the holes have been drilled to the proper size. Now let's remove the tape and clean up and sort of chamfer the holes so there's no burrs on either side. Well, the holes are all cleaned up on the outer surface, and then on the inside there's all kinds of burrs and other pieces of sharp steel, and what I have done is take a chisel and hammer and tap around the hole, and you can peel away all of that kind of flash that builds up when you drill. Okay, I'm in the process of doing that. I've got about 90% of it out now. Then I'll go over this with some coarse sandpaper to smooth out the edges. Now the inside has no burrs or anything that will interfere with the installation of the components at the bottom of the chassis. One final step in completing the bottom surface of the chassis is to drill all the screw holes that will hold the tube bases in place. I've marked them. I will now dimple them with the punch and drill them out. Okay, the holes are all drilled, and now it's time to move on. Well, it's a Festivus miracle. Look what just showed up. The long-awaited parts order from Antique Electronic Supply. Let's get it open. They didn't back order anything, which is pretty typical for them. I don't think I've ever had them back order anything. So we'll get it open and get out our parts, and we'll continue with the preparation of our chassis. One point to be made here is this was sent by USPS Ground Advantage, and it's a tiny bit cheaper than Priority Mail. And I don't think I'll ever use it again, because apparently, judging from the trip that this box took to get here, they just throw it on the next truck out no matter where it's going, and hope to God by the law of averages that eventually a truck's coming by your house. But I'll never do this again. Priority Mail would have been there in like two days, maybe 3 days, instead of 7 or 8 like this Ground Advantage. So in this case, this whatever dollar saved was certainly not worth it. Well, it's Christmas in April. Here we have our power transformer, reverb driver, output transformer, shielded cable for our reverb cables to and from the tank, the 6 ANA tube that I didn't happen to have, and about 9,000 other miscellaneous small parts. particularly resistors. I'm sick and tired of being halfway through a circuit and I don't have the exact resistor I needed, so I just ordered 5 of every one in the circuit. All these parts are listed on the parts list. Now bear in mind, I only ordered the ones I didn't have already, but other than resistors. But so I'll open this a little later. But I couldn't continue with the preparation of the chassis until I had the 3 transformers. Now we can go in here and we can cut out our opening for the power transformer and decide where we're going to mount the output and reverb driver. Okay, then also we're going to have, I believe, our, like a doghouse back here with our electrolytic capacitors. I think best would be right beside our power transformer. So now that the parts have finally arrived, let's start laying out the rear of the chassis with these items. Now we want our power transformer to be as close as possible to our AC input and our toggle switch that will turn the circuit on and off, and to our rectifier tube. So naturally the best place I think to put it is right back here, and since it's a recessed power transformer, I'm going to have to cut an opening for this portion of the case of the transformer. Okay, so let's draw out the dimensions we need here and the location of the mounting studs and get started cutting out a inlet in the rear of the chassis. Well, this is what I've come up with. Okay, the power transformer right here adjacent to the rectifier and the AC input, and the toggle switch which switches everything on and off. So all of the AC will be down at this end. Notice that the axis of the power transformer is parallel to the chassis, whereas the axis of the output transformer is perpendicular. This will be the power supply here with the electrolytic filter caps and the internodal resistors. There'll be holes with grommets for them to interact with the circuit inside the chassis. The output transformer then will have a short run to the 3 speaker outputs, and our reverb driver is over here, hopefully isolated far enough from the AC so that there will be no interference. Okay, I think now it's time, the most difficult job of this, because these are surface mount. These are 2 holes and then a hole or 2 for the wires with grommets. These are easy, but I've got to cut out that rectangular inlet for this part of the power transformer, and then the 4 holes for the studs. So I'm going to do that. After I lay all this out, I'm going to do measurements to make sure everything is pleasing and balanced, and then I'll start cutting on the inlet hole, which sounds a little indecent, but isn't really, I swear. I've drilled the 4 holes for the studs that will hold the transformer to the chassis, and now it's time to take my most hated hand tool, the saber saw, and cut along this line here so that this centerpiece will punch out and make room for this protrusion from the transformer and allow these wires then to be within the chassis itself. Well, the cutout is complete, and the holes naturally had to be elongated a little bit in different directions to line up exactly, but now the transformer sits quite nicely on the rear of the chassis. Now it's time for the terminal strips, output transformer, and reverb transformer. The holes are now drilled for the 2 terminal strips that will hold the filter caps and internodal resistors. Now it's time for the output transformer. The holes are drilled for the output transformer, and also the holes where the primary and secondary windings will pass through into the chassis. They've been drilled large enough so that rubber grommets can fit in place to protect the wires from chafing. Now it's time for the reverb driver. So now the rear wall of the chassis is finished, and one last final step is to do the control panel. I have the final layout for the control panel, the high and low gain inputs, 4 potentiometer controls, the on-off toggle, and the color changing pilot light. Now, it's a shame I don't have the cabinet because it's going to overlap this control panel, and I'm not sure how far. I looked up on the internet, and apparently the cutout is allows 12 1/4 inches of the control panel to show. So that's the way I'm going to arrange it, and I'm hoping that the overlap is like down to here, maybe 1/2 or 3/4 of an inch, but that remains to be seen if and when I ever get the cabinet. Okay, so this is the way I'm going to drill it, and let's keep our fingers crossed that it's going to work when the cabinet gets here. Well, there is the finished control panel, all holes drilled and clearances checked. I'm not sure how far down the cabinet will overlap on this, but hopefully the components will be more or less centered front to back. There's 2 more holes to drill, but I can't do that till I get the cabinet, and where it overlaps here, there's going to be a hole on either side of the control panel that will come through the cabinet, and I'll have to drill through so that the nut and bolt can be installed on both sides to hold the chassis in place. So today has been a very productive one with all of the machining completed on the chassis, the top control panel, the rear where the transformers are mounted, and the bottom where all the tube sockets, speaker jacks, and reverb RCA jacks will be located. I guess I could go ahead now and paint this. As I said, I haven't drilled these holes to hold it in the cabinet, but that can probably be done without damaging the paint. So now to start thinking about a nice color for it. So while I ponder this momentous decision, this might be a really good stopping point for the Part 1 video. In Part 2, the cabinet will hopefully arrive and can be evaluated. The chassis will be painted and assembled, and the wiring will begin. So if that sounds like fun,